Hello class, welcome to the video. In this video we're going to talk about the testing population mean for two populations. We are going to look at the case of the independent sample. So I'm just going to write this thing down so you guys can see this. So the testing so test view of two populations okay, now we're going to put our restrictions for independent samples. This means that we're going to have to use the t-table distributions. Okay, so we'll talk about that. Alright, now if you look at the questions, we are talking about the medication that helps the person with the bipolar depressions, and we want to find out if the medication is working. So what we have here is that if you look at the data, the placebo group is just the group that taking sugar pills. Then the medication group is the second one that taking the medication to help bipolar depression there. Now one thing that we have to be careful here is that I did not write that subscript here, so I'm just going to rewrite this for you. So placebo group here is going to be N1. I'm just going to putting it over here. N1 equals to 43. And X bar 1 equals to 21.57, and then S1 equals to 3.87. Okay, now for the medication group we're going to call it N2, which is a 33, and the X bar 1 is equal to 20.38, and the S1 equals to 3.91. Alright, so we're going to start the testing over here. So let's just look at, remember that this is a two population. So we talked about in class that you're going to have to write the original claim and the null hypothesis and alternative hypothesis in terms of two population, mu1 and mu2. So I'm going to call the placebo group mu1, and the medication group I'm going to call it mu2. Okay, so the original claim here is that if you read the question there, use alpha equals 0.05, that they both have the same mean. Okay, whether you take the medication or not, the scale is the same. So we are saying that mu1, those who do not taking the medication and those who are taking medication, the score is the same. Now the competing idea, now remember this is a complement of the original claim, so that means mu1 is not equal to mu2. Alright, now let's find out what the null hypothesis is. So it's going to be always equal, so you're going to get mu1 is equal to mu2. Now remember, our alternative hypothesis has to be lesser or greater or not equal to, so in this case it's going to be a competing idea. So that would be a mu1 is not equal to mu2. So this tells us that we have a two-tailed test. Okay, and we are given that alpha equals to 0.05, and since we are using the t-distribution table, we have to find the degrees of freedom. And I told you that in class, if you are testing two populations, you always take the smaller degrees of freedom here. So if you look at the second one is a 33, so you're going to have to use that. So 33 minus 1, we get 32 degree of freedom. Now let's find the critical value here. So here is going to be a T critical value. Okay, so now we're going to draw the picture. Okay, now remember this is a two-tailed test, so we're going to have to divide this by two-tail. Okay, so two-tail here. And since the alpha is a 0.05, right? So alpha over 2, because we have two different areas of a shaded area. So alpha over 2 is going to be 0.05 over 2. So that would be 0.025. And same thing on the other side also, right? So alpha over 2 is a 0.025. Now let's go to the T critical value here. So you're going to have to go use the different table now. Okay. So if you go to the T distribution table, we have either area of two tail or one tail. In this case, it doesn't make any difference because they are two tail there. So in the one tail or two tail, it should be 0.025 and 0.05, which is the third column from the left. Now you'll have to go down to 32. So if you go down to 32, and you will see the critical value is going to be 2.037. So here, T critical value on the left hand side has to be negative. So there will be a minus 2.037. And on the right hand side, it's going to be positive 2.037. Alright, so that looks good. Now number 7, we'll have to find the test statistic. Now remember the two population test statistic is a little bit different from the one population test statistic, and you will need to go back to that insert and use the two population test statistic for independent sample. Okay, so that would be x bar 1 minus x bar 2. Now minus 0, because mu1 minus mu2 is going to be always equal to 0, right? So we're just going to put that 0 there. And then we have a square root of s1 square over n1 plus the s2 square over n2. Alright? So now we're going to find out what that is. So x bar 1, we get what? 21.57. And x bar 2 is a 20.38. Now, I'm going to plug that in. Now remember the S1 square, S1 is 3.87. And divided by N1, there's a 43, plus S2, which is a 3.91, squared divided by N2, which is a 33. Okay, so let's find out what we have here. So first, on the top, we have 21.57 minus 20.38. So that would be a 1.19 on the top. Let's find out what we have at the bottom here. Okay, so you got 3.87 square divided by 43. So under the square root, I have 0.3483 plus, now let's do the same thing for 3.91 square divided by 33, and I have a 0.4632. Okay, so I'm going to add these two numbers, 0.3483 plus 0.4632. Then we're going to take the square root. I have a 0.9 at the bottom. So you got 1.19 divided by 0.9. Okay, so 1.19 divided by 0.9, I have 1.32. That's the positive 1.32. So now we are going to place this in on the graph here. So now the critical value on the right hand side is 2.037, but the test statistic was 1.32. So that's going to be left hand side here. Right? So you got T test statistic equals to 1.32. And since the test statistic does not fall into the critical region, we fail to reject null hypothesis. Okay? And if you go through that, the flowchart one more time, we have, does the original claim contain equality? Yes, it does. Do you reject them? Yes. So the conclusion should be there is sufficient evidence okay. We don't, never mind, we do not reject, right? There is not, sorry about that. There is not sufficient evidence, okay, to warrant, okay, rejection of the claim. Okay, that mu1 is equal to mu2. So it seems like that whether you take the medication or you take the sugar pill, you know, the scale, the I guess Hamilton depressed scale is pretty much the same. So that tells me that medication is not working, I think. Alright, so that was the two population test here. Now we also went over that, setting up the confidence interval here, right? So we're going to go over that for two population there. So I'm going to use the green over there. Okay, so remember that the setting up the two population confidence interval was x bar 1 minus x bar 2. Okay. And the minus margin of error, and the mu1 minus mu2, then you got x bar 1 minus x bar 2 plus the margin of error. So now we're going to have to find out what the margin of error is, right? So I'm going to have to find the margin of error, so I'm going to do it up here. So margin of error here is whatever you see at the bottom there, okay, at the hypothesis test, okay, and the we're going to use that, okay, when you try to set up the confidence interval there. I'm just trying to find out where the thing is, because if you go to that confidence interval, you will see that two population there, okay. So margin of error is going to be, okay, since we don't know what the population standard deviation sigma is, this is going to be T alpha over 2 square root, and whatever you see on the right hand side is going to be there. So you got S1 square over N1 plus the S2 square over N2. Now, so let's just go to the T alpha over 2. Okay, now remember that this thing happens to be the two-tailed test. So if you go to that, critical value, you will see that 2.037 same as a critical value there. So we're going to use that 2.037. Okay, and then after the square root after the bottom portion is going to be 0.9. So we're going to multiply that by 0.9, and that's going to be our the margin of error here. So let's just find out what that is. So we have a 2.037 times 0.9. I have 1.83. So that would be our margin of error. Now we're going to come here, x bar 1, x bar 2, it was the 1.19. So we have a 1.19 minus margin of error, which is a 1.83. Mu1 minus mu2, and x bar 1 minus x bar 2, which is a 1.19, plus the margin of error, which is 1.83. Okay, so now let's look at the left hand side. So we have what? 1.19 minus 1.83. I have minus 0.64, and mu1 minus mu2, you got 1.19 plus 1.83. I have a 3.02. Okay, so the interpretation should be, we are 95% confident that interval from minus 0.64 to 3.02 does contain the population mean of mu, right? Now, one thing that I ask you to the class is to recognize that, okay, that the if this interval contains the 0 here, in this case, if I just go back up here and I'm going to show that interval here. So here's the minus 0.64. Then you have the 3.02. So now the 0 is in between here, right? So there's a 0. So if the confidence interval contains a 0, okay, which means that mu1 is equal to mu2, it means that it contains the notion that nothing's happening. So if your confidence interval contains a 0, then it kind of tells us that nothing's happening in the populations. Just like when you find out the result from the hypothesis test, confidence interval also can tell you, okay, whether the null hypothesis is true or not. Okay, by looking at the interval and see if the interval contains a 0 or not. So if the interval contains a 0, you fail to reject. Nothing's happening there. But if the confidence interval does not contain 0, then you can say that there's something's going on. Okay, null hypothesis is not true. Okay, so those are the two things that we talked about in class. Okay, so testing two population is a bit involved, but as you can see, the procedures going through the entire process is not much different from the doing it with the one populations. Additional thing here is that when you test the two populations, you can also do the confidence interval, and can come up with the same conclusion as your hypothesis test by finding out whether the interval contains a 0 or not. If it contains a 0, then nothing's happening. If it does not contain the 0, then something is happening. Okay? So if you have any further questions, you can always come by my office or ask me during the office hours, or you can come to talk to me after class, before the class. Okay, just ask me, then I'll try to help you. All right, thanks for coming. I'll see you in the next video. Bye.